And so I'll continue to let people in. Welcome, welcome, everybody. We're going to review for the Unit 2 test today. But before that, some announcements, just some reminders of things going on at the school. IXL diagnostics. I'm assuming you've done them or you've communicated with your homeroom teacher that you're getting them done because you're here and you're not locked out. So get those done. I did throw in some pictures. So remember I was gone last week and Miss Sill held live lesson, but I was in Alaska and these are my favorite pictures. So cool. I was a fin whale and then I got to see a real life glacier and I got to see it calve and like the ice breaking off. So neat. Highly recommend it. Really? Have you been up there? I mean, Alaska, it's gorgeous, but extreme. I don't know if I'd want to live there. We have our first field trip is planned. I hope you guys can come. We have in the north and the south next Friday. So not tomorrow, but a week from tomorrow, we will be bowling. It's only $8 a person. We got deals on at both places. So come on out and meet some classmates and have some fun. If anyone here is interested in joining student council, so they do assemblies, they plan field trips, they do a lot of different activities. You missed the meeting about, or maybe you did go, but there was a meeting about how to join student council and run for an office, but you can still sign up if you want. Oops, let me get the couple things for you in the chat. If you're interested in student council and being, active with the school, you can go to that website for information. Here is the form to sign up and say that you're interested in being, having a position. You don't have to have a position to be in student council, though. Like you can still go to the meetings and just be active and get to know other classmates. You don't have to, represent your class, officially. But if you are interested in having a student council position and, it looks good on applications and stuff like that, then you can fill out that form. So get involved with the school. It's one of the many ways to get involved. Okay, so we have the Unit 2 test today. We are going to do, I call it a 90-second review, a quick review about what you learned in Unit 2, and then we will play Kahoot to get ready for the test. Okay, so Unit 2 is all about atoms and how they're organized and how they bond. So just a quick review. Atoms are made of electrons, protons, and neutrons. Protons are positive. They're in the nucleus with the neutrons, and all the electrons are in the energy shell, the outer shell, in an organized fashion, but kind of floating around chaotically. Organized chaos, right? All the different atoms on the planet can be found on the periodic table of elements. And it looks, you might not notice it and say, oh, there's a lot of meaning and organization to where things are, but there really is. I love it. I love a well-organized data table. On the periodic table, you will see, different things. One, the element symbol that we use, it's like a shorthand. So it's usually one or two letters, but then you have the full name. So like carbon, we use C. The atomic number, the elements on the periodic table are organized by the atomic number, and the atomic number tells you the number of protons. Elements are determined by the number of protons. You can change the neutrons and electrons and still have the same element. But if you change the protons, you have a completely different element. It'll tell you the atomic mass, which is the amount of protons and neutrons. And it's always like kind of a, maybe not a whole number because there is different isotopes. So if there's different number of neutrons that naturally occur. So usually the atomic mass is the average of those isotopes. So it gives you an idea if like isotopes are common. So for carbon, being close to 6, so there'd be 6 protons, 6 neutrons. There's not a lot of isotopes of carbon out there, but other elements are different. So those are some of the symbols that you see. So here's, nitrogen 14. So that gives you the atomic mass. And then the atomic number is 7. So there's 7 protons. Then there should be 7 electrons and 7 neutrons. And because the mass is 14, then we know that there's 7 neutrons. I think all of these are, not isotopes. They have the same number of protons and neutrons. But if this was different, like let's say this was 23, it would tell you that there's 1 less neutron than proton and that it's an isotope. But there aren't any questions on isotopes. But that's, if there's a different number of neutrons, then it changes the atomic mass. Now, electrons are organized in the outer shell. There's different levels, different energy levels. The first energy level can only hold 2 electrons. The second energy level can hold 8. The third energy level can hold 8. And then the fourth can also, I think it holds 16 actually. But we're not going to get that complicated because this is not a chemistry class. But the electrons in the outer shell are organized in different levels. And when a level is full, then the electrons go to the next level. Okay. One beautiful thing about the periodic table is you can tell how many energy levels there are and how many electrons are in the outer energy shell. So the outer energy shell is the one on the very out. So magnesium has 1, 2, 3 levels, and there are 2 electrons in the outer shell. Calcium has 1, 2, 3, 4, and there's 2 in the outer shell. And again, I'm going fast because this is all should be a review from the lessons. The periodic table, you can tell how many electrons are in the outer shell and how many energy levels there are. So hydrogen that has 1 electron it's in group 1, so it has 1 electron, or sorry, it has 1 proton and 1 electron. So it only has 1 electron in its outer shell, and it's in group 1. Helium, it's a little bit weird. It has 2 electrons and it has 2 protons and 2 electrons and 2 in its outer shell. It is in group 18, and it doesn't have 8 in its outer shell. But it has 2. Its outer shell is full. Okay. Lithium, if we go down here, now we're in the second energy level. It has 3 protons. So it would have 2 in that first energy level. And then 1 is going to be in that second energy level. So it's in period 2. And it's in group 1. So group 1, all of these have 1 electron in its outer energy level. Group 2, all of these have 2 electrons in its outer energy level. These guys here in the middle, they're weird. They're metals. Metals behave differently. They have all sorts of different rules. So we're going to kind of ignore this region. But then if we get over here to group 13, all of these have 3 electrons in the outer energy level. All of these have 4, 5, 6, 7, and then 8, but except for helium, it only has 2 because it only has 2 protons total. So it only has 2 electrons total, but it's still, its outer energy level is full. So here's an image of that. So you got hydrogen, helium, kind of showing that even though the atom is getting bigger, so as you're moving down the periods, your atoms are getting bigger because there's more protons, more electrons, there's more energy levels, but they have the same number in the outer shell. They all have the same number in the outer shell. And this is important because atoms work to fill up that outer shell of electrons, and it will bond with other atoms to do that. It'll behave in ways to do that. So either it'll create ionic bonds where there's a transfer of electrons. So like sodium needs, I think it's 2. Let's go find it. Sodium, where's sodium? Yeah, sodium, it has 1 extra. Okay, so it only has 1 electron in its outer shell. It will easily give that up. So then its outer shell, its outer shell is full. It only has 8. And chlorine has 7. It needs 1 more. So it'll take electrons from other atoms. So sodium and chloride often bind together. Sodium giving up an electron. So now it's positive. Chlorine taking an electron. So now it's overall negative. And then that negative and positive, attraction causes them to stay together. and this is salt. Often metals and nonmetals, when they bind, they create ionic bonds. Atoms can share electrons, so the electrons go back and forth, and carbon is kind of a special molecule where it's small and it needs 4 electrons to fill up its outer shell, and will often share 4. And then metals are kind of fancy and different. Like I said, they do this thing where there's like free electrons that move around, and that kind of like keeps them all together. So iron will do that. And this property, this metallic bonding, is what allows metals to be such good conductors of electricity. Metals are also malleable. They tend to be solid at room temperature. There's some questions on that. All right, another thing you can see in the periodic table is the electronegativity trend. So electronegativity, as you learned, was like the desire for that atom or element to get those extra electrons, how much it's going to like fight for it or pull them. The smaller the atom, the stronger the electronegativity, and the closer it is to getting its full energy level, is the higher the electronegativity. So fluorine is the most electronegativity atom out there. All right, so it only has 2 energy levels, so it's smaller. So all those electrons are close to the nucleus, and it only needs 1 more. So fluorine is the most. Oxygen is the second most. There's another kind of picture showing it, the electronegativity. So again, how much is like, give me that electron. I want that electron. I need it. And that rule of like filling out that outer shell is called the octet rule. Okay, that was our as quick as I could review about what we are studying or what we studied in Unit 2. May have, missed some of the smaller things, but we are going to play Kahoot. So you can join. I did my best. So you can click on that link to join Kahoot and put in the game pin. Or if you have it on your app, you can open the app. Or if you want to scan this on your phone, you should be able to join that way. Yeah, I went through how many lessons did we have for this unit? So those are the big things that we learned about. And if you want to use, a nickname, because you don't want people to know, who you are, like if you're missing it or something. I don't know, if you're embarrassed or whatever, feel free to, as long as it's school appropriate, whatever you want. So I have 10 in the Kahoot and there's 22 in the class right now. So I'm assuming some of you are still trying to get in. I'll give you a couple more minutes. I see a lot of ice creams on the head. Oh, they're going away. I like the lizard that looks like Albert Einstein. I just give you like 30 more seconds. You can always join even after we start if you're having trouble. Or if you're having trouble, let me know. All right. Let's get this party started. Our first question is, which subatomic particle has a positive charge? Neutrons, protons, electrons, or photons? Yes, most of you got it correct. It is protons. So protons are positive. I always remember protons positive. Electrons are electrifying and they are negative. Neutrons are neutral. Photons are not part of atoms. That was the one to throw you off, you know? Let's see. Emma, Josiah, Kimberly in our top three, followed by Justin and Todd. All right, our next question is, if you know an element's atomic number and mass, what information can be determined for a neutral atom? Only the valence electrons, only the number of protons and neutrons, the number of protons, neutrons, and electrons. You can't determine anything. You know its atomic number and its mass, and then it's neutral, meaning it has no charge. You're going to just throw in a guess. You got 2 seconds. Yes, the protons, neutrons, and electrons. So if you know its atomic number, those the protons, you take the mass and minus the number of protons, that gives you the neutrons. And then if it's neutral, it has to be the same number of protons and electrons. Let's see. Woo! We got a little switching up there. Capri and Jazz, welcome. Leaderboard. All right, if an atom has an atomic number of 11 and a mass number of 23, how many protons does it have? 11, 23, 12, or is there not enough information? How many protons are there? Yeah. Oh, it should be based on the number. So there is a mistake on this quiz. And I'm wondering what the question is on the test. So the number of protons is 11. So those who put the red one are correct. But the number of neutrons is 12. And I don't know which one is on the test. But either way, you're going to know what's the answer on the test. So this is going to mess up our rankings. I'm sorry. But the correct number of protons is 11 because atomic numbers is the proton. I will change. I'm going to put a note. What question was this? To fix that on my Kahoot game. I must have changed something and then forgot to correct the answer. So I'm sorry. So I know it's messing up the who's on what, but the protons was 11 because the atomic number is the number of protons. But my key was wrong, and I'm wondering if I should have written neutrons, and if on the test it says neutrons. These are the questions from the test. All right, question 4. Hydrogen has an atomic number of 1 and a mass number of 1. Why? You got it wrong, right? Hydrogen doesn't have any neutrons. Hydrogen is stable. Hydrogen has 2 electrons. Hydrogen is the first element on the periodic table. So it has atomic number of 1 and a mass number of 1. Give me another 10, 5 seconds. There's 2 people that need a guess. Yes, hydrogen doesn't have any neutrons. Hydrogen, how it naturally appears for the most part, is an isotope without any neutrons. So it's just 1 proton in its nucleus. There's probably a few out there that have neutrons in there, but for the most part, it doesn't. I don't know why. So it Its mass number is 1, and it's 1 because of that. And it's true that it is the first element on the periodic table, but doesn't explain what's happening there with the mass and the atomic number. Let's see. Emma, Kimberly, Todd, Jazz. Moving up. Justin still holding on as number 1. All right. How is the current periodic of table elements organized? By nucleus size, by atomic number, by atomic weight, or electric charge? And I realized I didn't share my screen to share the music, and you're missing out on the Kahoot jams. So I'm not just dancing along to music in my head. There is music playing on Kahoot. Yes, atomic number. I'm glad no one put a nucleus size because, it's true as the atomic number increases, nucleus size will increase, but it's not always 100% because of those, isotopes, those crazy isotopes. But yes, atomic number. Let's see. Woo! Josiah and Landon is white. Moving to the leaderboard. Question 6. Which is bigger, Krypton, atomic number 36, or Xeon, atomic number 54? We can't tell. They're the same. Oh, you don't like that Kahoot music? Oh, you're about to what? I missed. So which one is going to be a bigger atom? Oh, click the nucleus. That's okay. It's okay to miss it here because, that's not the test. Correct. Xeon, it has more protons and neutrons, so it's going to be bigger. Good work. Justin's on fire. All right. Question number 7. Which element has 2 valence electrons? Is it hydrogen, fluorine, there's calcium? Where's the other one? CS. Where are you? Oh, I can't find it. It's on there somewhere. I know it is. Oh, down here. CS. There it is. Which one has 2 valence electrons? So 2 electrons in its outer shell. Yes, calcium. We can bring that picture back. It's in group 2. So remember, you can tell how many valence electrons each atom has based on the group that it's in, except for those middle guys because they're weird. But it was in group 2, so it's 2 valence electrons. And you can also know that calcium is, it has 2 extra electrons. It wants to have that valence shell full. It'll easily give up those electrons to be, stable. And so it'll is often found as an ion, a 2 positive ion. There are 3 people on fire. Good job. Pat yourselves on the back. Question 8. Which element has more valence electrons, chlorine or argon? Okay, chlorine is right here. Where's argon? Argon's right here, right next to it. So which one has more valence electrons? More electrons in its outer shell. Yes, argon. So argon is what's considered a noble gas. It has 8 electrons in its outer shell. Its outer shell is full. Because it's already full, it doesn't really react with anything. So anyone in that group 18 doesn't react much. So it has more electrons in its outer shell than chlorine. Chlorine has 7. It wants 1 more. So it often will take an electron from someplace else and be negative. Woohoo! Justin, nice job. Answer streak of 8. Question 9. Why are the noble gases the least reactive elements? I just gave you the answer. These elements have the smallest atomic mass. These elements have an empty inner electron shell. These elements have a full valence electron shell. Or these are the most electronegative elements. Kim's trying to throw you guys off. So why are those noble gases the least reactive? If you don't remember, oh, you guys are so good. Everyone, most of you got it. Element, full valence electron shell. They are, yeah, because they're noble. They're the one in group 18 all the way to the right. They don't need or want any more electrons, or they don't have any extra ones to give away. They're happy and content. Josiah, good job. All right, true or false? The octet rule states that atoms want to have 8 valence electrons in order to be stable. True or false? Yay, everyone got that one right. That is true. Lots of points. Question number 11. How is electronegativity defined? The overall number of negative charged particles in an atom, the tendency of an atom to attract electrons in a bond, the tendency in an atom to give up electrons, the overall negative charge of an atom. Remember, smaller atoms are more electronegative, and ones that are almost filled, valence shells almost filled. Yes, don't see we got this. The tendency of an atom to attract electrons in a bond is like how badly it wants it. It will pull those electrons. And it's important for like oxygen, why oxygen and hydrogen form polar covalent bonds. But we don't need to know that at this point. But it has important ramifications. Justin, you are still on fire, man. Question number 12. An element has 2 valence electrons. What charge will its ion have? Is he hacking? Can you hack the game? I don't know if you can. So if you have 2 valence electrons like calcium, I didn't know you could hack the game. You'll have to share these secrets. So then I can do it in our staff meetings when we play Kahoot. So 2 valence electrons. Yes, it will be a 2 positive. So if there's only 2 in your electron outer shell, you need 6 more to fill up that shell, which is kind of a lot. So it's easier to give up 2 than it is to get 6. So they'll typically give up 2. And so now it's going to have 2 less electrons than protons. So it'll be 2 positive. Good work. Justin, hacking it. But Kim's hacking too. Carbon has 4 valence electrons. How many electrons can it accept from other atoms while bonding? 8, 4, 6, or 2. Carbon is known to make a lot of covalent bonds. There's a whole area of chemistry that studies carbon and its bonding and its molecules called organic chemistry. So if it has 4, how many more does it need to have 8? Yes, it needs 4 more. Woo! Points, Justin. Question 14. What type of bond results from atoms sharing electrons? So they share electrons. Is that ionic, covalent, hydrogen, or chemistry bonds? So they're sharing. The electrons go back and forth. It's a bonding bond. Yes, a covalent bond. So the electrons go back and forth. There's no charges. So the ionic bonds are when they give up electrons. Oh, look, I've never seen that reaction. You guys are teaching me so much. Jason, answer streak of 11. Nice job. I don't know if you're hacking or not. Maybe everyone is. You're going to have to teach everyone how to hack. Question 15. What type of bond forms between a metal and a non-metal? Is that ionic, covalent, metallic, or hydrogen? I did mention this quickly when we were talking about bonding. So between a metal and a non-metal, what type of bond would form? Wait, someone hacked you? Now people can hack each other in the game? Mind blown. It is an ionic bond. So a metallic bond is a bond between the metal ions. So like if you just have iron, those electrons move around the different iron elements. So it doesn't bond it with any other type of element. And that's what makes metals such good conductors. But if you're doing a metal with a non-metal, then it's going to be an ionic bond. Someone's giving up electrons, someone's accepting them. So that one is a little confusing, but remember, a metallic bond is just between the elements of the same metal. Woo! Emma taking over Justin. Maybe Emma knows how to hack now. I don't know. Question 16. Which statement about metals and nonmetals is correct? Metals are poor conductors of electricity. Nonmetals are strong. Metals are solids and nonmetals are liquids. Metals are on the right side of the periodic table, nonmetals on the left. Metals can be hammered into thin sheets and nonmetals are brittle. Yay! Yes. So metals can be hammered into thin sheets and nonmetals tend to be more brittle. They can't be those thin sheets. Metals are good conductors of electricity. Nonmetals tend to not be good conductors. Metals and nonmetals can both be solids. And then metals are in the middle of the periodic table. They're those weird guys. Nice job, Jason. Answer streak at 13. That's impressive. All right. Last question. Which of the following is not a characteristic of metals? That they're dull, that they're lustrous, that they're malleable, or that they are ductile? Correct. They're not dull. They're not dull and boring. They tend to be shiny. So lustrous is kind of in that. And they're easy to, bend and move around, make lots of different shapes. That has to do with the metallic bonding too, part of that. So yeah, let's see who ended up on our podium. In third place is Kimberly. Nice job. And second place is Justin. That means our first place person is Emma. Like I say, well, you guys are new to my class, so what I would say is that you're all winners because you got a good review for the test. If you missed any questions here, you're not going to miss them on the test. All right. So I'm going to put this away. That's not what I meant to do. Close, close, go away. Here we go. I want to briefly talk about the test questions. There are 2 to 3 test questions, depending if you are in honors or not. We will play more Kahoot. Just not today. There are 2 to 3 questions on the test, and all the questions are pretty much the same on every test, where I have you pick something that you learned and you tell me about it in 4 to 6 sentences. So tell me what lesson or lessons it is, and describe it. So if you want to talk about, how protons and electrons are, like what an atom looks like, you can talk about, where to find the protons and electrons, what's negative and positive and neutral. If you change the electrons, you have an ion, that sort of thing. You can talk about how, you can spend one talking about the different types of bonds there are, covalent versus ionic versus metallic. You can spend one talking about metals. Like there's lots of different things that you can do. You just need to pick 2 different topics. And again, show me that you learned something about that topic. So I hope that that is an easy question and doesn't feel stressful. Any questions on the essay questions? No questions? The essay questions are too long. So if you are in standard, there's 2. So if you're not in the honors class, there's 2. If you're in honors, there's 3 or 4. I can't remember. You have more essay questions if you're in honors. Okay, so then you have more than 2. So in the test, so when you go to take your Unit 2 test, I actually put them at the top of the test. So the first questions will be the essay questions. And you can write them before you start the test if you want. You can review your notes. Just make sure you're talking about things that are actually covered in the lessons. When people are talking about things that are not covered in the lessons, then I know that they're using outside sources. So if you're going well beyond what the course is covering, then you don't get any points. Okay. So that's everything for the test. I'm stopping this recording.